Welcome to the Real Python Podcast. This is episode 191. How do you manage the dependencies of a large-scale data science project? How do you migrate that project from a laptop to cloud infrastructure or utilize GPUs in multiple instances in parallel? This week on the show, Savin Goyal returns to discuss the updates to the open source framework Metaflow. Savin briefly describes the Metaflow platform and the goal of simplifying engineering overhead for data scientists and programmers. We discuss how the platform captures snapshots of a project as you work, allowing you to go back in time or share the state of your project with another team member. We dig into the complicated process of managing dependencies for machine learning and data science projects. Savin describes how the required external libraries can be specified within a flow with the new @PyPI or @Conda decorators. This allows a project to scale from a local machine to the cloud or multiple instances with all dependencies included. He talks about starting a new company, Outerbounds, with fellow coworkers from Netflix. Their vision is to continue to build the Metaflow open source platform and offer customers scalable enterprise-grade infrastructure. This episode is sponsored by Intel, providing Edge AI reference kits. Are you building AI apps with popular models like YOLO V8 or Padim? If so, check out intel.com/edgeai to get open source code snippets and helpful guides. Just go to intel.com/edgeai. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Savin, welcome back to the show.
Thanks for having me back, Christopher.
Yeah, I'm excited to talk to you about, lots of little changes and updates to Metaflow. I thought maybe we could start talking a little bit about what's been happening with you. You were working at Netflix when we talked last, and it sounds like you've been able to take advantage of some of this work that you're doing with Metaflow and expand a little bit here. So do you want to talk about that a little bit?
Yeah, sure. I think when we last spoke about Metaflow, we had recently open sourced the project at that particular moment. As you can imagine, throughout the early innings of the pandemic, there's considerable digitization that happened all across the board. Organizations' appetite to invest in data efforts or ML efforts that increased substantially, and that naturally led to an uptick in the take rate for our project as well. We had plenty of companies that started using Metaflow in non-trivial use cases, and that presented itself an opportunity to make it something bigger than what it was. So then me, alongside a few of my colleagues at Netflix, we decided that right now is a good time to spin out of Netflix, start a company that's focused on the development and continuation of Metaflow, and here we are.
That's great. Netflix is still involved. They're still using a lot of the stuff that happens inside there. It seems to be still a prized project within that organization.
Yeah, definitely seems to be the case. The team that's responsible for Metaflow internally at Netflix, that has only grown ever since my departure. We collaborate very closely with them. Many of the features that you see getting shipped out in open source, good work from the team back there. So yeah, happy and excellent partners for us.
Oh, that's great. Awesome. Do you want to talk a little bit about what Outerbounds does?
Mm-hmm. Yeah. At Outerbounds, our vision is to build a platform that can take care of all your data science, ML, and AI needs. In many ways, that was the charter that we had back at Netflix as well. But now you can imagine in any large company, you are basically standing on the shoulders of the giants. Of course, we were responsible for building ML infrastructure for Netflix, but we were standing on top of all the good work that other platform engineering teams at Netflix were doing, teams that were responsible for provisioning the data platform, the compute platform, teams that were managing the workflow orchestrators, teams focused on observability, and so on and so forth. And You can imagine now, if you look at other companies outside of, let's say, the FANG ecosystem as well, what's common between Netflix and all of these other companies is that predominantly all of these companies also run similar-ish infrastructure
Yeah.
as what Netflix runs, thanks to the fact that Netflix is on the public cloud, right? And I think that was one of the big reasons why Metaflow has seen a lot of successful adoption in all of these rather sort of like scaled out companies. But that also presented an interesting challenge, because then many of these companies, many of these organizations are also trying to figure out, how do we create a compute platform for machine learning? How do we think about data platform for ML? And with Outerbounds, we are trying to solve all of those problems as well. So Outerbounds, the product that we are building, basically provisions a compute platform, a data platform, workflow orchestrators, a full observability stack for an organization that's interested in investing in the latest and greatest ML tooling. And all of that is then bundled with Metaflow as sort of like the user experience layer that data scientists interact with.
Yeah. I could see the having talked about all of the different components involved in this process, how having the ability to get them under one sort of shingle would be advantageous to somebody looking at it. I've been talking a lot about the compliance in some organizations. We talked about that when we talked about Python inside of Excel, and how Microsoft, the compliance is already sort of done in a lot of cases for these big organizations and so forth. So I can kind of see some advantages there. So that's really cool.
Yeah.
What we could do maybe briefly, if people hadn't listened to episode 61, which really they should have by now, just kidding. They could go back and learn a lot about the fundamentals of the platform. And obviously we're going to talk about it and kind of talk about what's changed and what's improved and all the things that have happened the last 2.5 years, sort of intersecting with our conversation here. Gosh, the AI, how much that's changed this environment, and also just how this stuff has sort of exploded as far as like, what's needed, and having a tool like Metaflow being useful. There was a really great talk you did. I forget the exact title, human friendly production ready data science with Metaflow. And there was this at SciPy in 2022. So I'll include a link to that, which is again, a good like grounding if somebody would like a video kind of showing you what's going on. And I really enjoyed the questions and answers that you did at the end there. But maybe you could kind of briefly, get people's feet wet if they've never heard of Metaflow and what's going on there. And we'll kind of get them up to speed. And then we'll start talking about some new functionality.
Sure. Yeah. Happy to do that. So Metaflow at its core is a machine learning platform. So we started building Metaflow back at Netflix in 2018, and it was geared to serve the needs of data scientists. As you can imagine, in any organization that is looking at reaping the fruits of machine learning or AI these days, there are two barriers of complexity that a data scientist needs to cross. So one is complexity around just data science.
Yeah.
Right. What data assets do you have available? How do you think about translating a business problem into a data science problem? What machine learning training frameworks are you using? If you are doing any kind of feature engineering, then how would you want to do that? If you are thinking about neural networks, what sort of like is the thought process? So there's an entire sort of like complex landscape on that front.
And these are the conversations that data scientists always have at lunch and are talking to each other about.
Exactly, right. I mean, data scientists are very motivated to tackle these problems. That's the part of the job that they really enjoy doing. And then there is the reality of operating within an organization and delivering actual business value, where you also need to interface with internal business systems. You also need to interface with complex engineering systems. If you have to train a large-scale model, then you have to figure out that, okay, how do I work with my compute framework? Because it is very likely that you wouldn't have necessary compute resources on your laptop. Now, if that sort of like ends up being a Kubernetes cluster, then is there an expectation that you're also an expert in Kubernetes? Or if your data
Right.
lives in some sort of like object store, then how do you figure out what is the best way to store that data, access that data, make sure that your GPUs are forever engaged? And how do you operate in, let's say, large teams of data scientists? How do you think about reproducibility as a first-class concern? So there's sort of like this value of complexity that presents itself.
Yeah.
That can be quite bothersome and can also result in loss of significant productivity in data science teams. And that's basically what Metaflow is aiming to solve. So the philosophical goal with Metaflow is that we want to take care of all of these problems that a data scientist does not enjoy tackling, as well as at the same time preserve their freedom of choice, their freedom of exploration to experiment freely in areas that they really like to dabble in, right? We don't want to have opinions on our side that how people should be thinking about machine learning or how people should be thinking about deconstructing their problem. But of course, we want to take away the pain of managing your compute environments, managing your data platform, managing all the small little pain points that sort of like occur on a day-to-day basis. So that's basically what Metaflow is in a nutshell.
And then there's just a lot of like details that you go into, and not only the video that you did at SciPy that we discussed in quite a lot of detail. We talked about all these sort of additional value added things that are in this platform, and the platform's only grown and gotten better. And one of the big ones that we focused on was this idea of snapshots, which is a really kind of fantastic idea that a lot of other platforms that I don't really hear that term, which is really kind of neat. This idea of being able to look at how things were set up and have this sort of consistency, this idea of being able to move from a laptop to a Kubernetes cluster or whatever, or all the steps kind of in between, this sort of reproducibility. So there's a lot of kind of really neat things. If you're thinking about infrastructure, it's a really great open source solution for that and kind of building it up. So I was very impressed with that. I had Calvin Hendricks Parker on to talk about Apache Airflow, and we talked about, is it directed acyclic graphs, DAGs? I don't know if I got that exactly right, but this idea of a tool like that of creating these workflows. But again, a tool like that is only one of the components that's there. And the idea of Metaflow is really to kind of glue all of those kind of pieces together in a lot of ways. And so what I thought we could build on top of it, to kind of talk about, is these updates and how software has been changing so much inside of Python. You know, Python itself as a language is on an annual cycle. I just did an episode where I talked about NumPy version 2 coming along, which is going to shake up a lot of people's projects potentially, which will be interesting. And so one of the things that you have been sort of thinking about tackling in this idea of reproducibility is, well, how can people that want to look at recreating these projects, you know, how can they kind of deal with it? And it sounds like you kind of been attacking it from a couple different angles. So maybe we can talk about it. The other kind of neat thing that I like about the platform is I'm a big fan of decorators, and it seems like you are too, at least as a platform. And so there's always kind of like new decorators that have been added to the platform that kind of highlight a lot of these features. And so maybe you can tell people about maybe we start with the Conda decorator, and then we talk more about the PyPI decorator and what they're trying to solve.
Yeah, sure. I mean, you can imagine reproducibility is a big theme in the world of machine learning. And usually when people think about reproducibility, it's more from the angle of, I have achieved certain results and I want to be reliably able to reproduce those exact same results. And of course, that enforces a lot more trust in the validity of the results that you are publishing.
It's crucial for science, right?
It's crucial for science, but it's also equally crucial for maintaining these machine learning systems.
Okay.
Right? Imagine if, let's say, things are not behaving as expected, if you cannot reliably reproduce that errant behavior either, then it becomes a rather non-trivial effort to diagnose what the issue is and let alone sort of like go about fixing it. So reproducibility sort of like cuts both ways. So when you are getting expected results, of course, it enforces your trust in those results. But when things happen out of the ordinary, then it also helps you figure out what really went wrong. And now, on that part, there are a few ingredients to reproducibility, right? Of course, there's sort of like the code that a data scientist is authoring, and that's something that's automatically snapshotted by Metaflow, so that you can walk back in time and look at any code that resulted in the generation of any kind of model or any kind of data set within the platform. Then the second thing is just having a thorough understanding of what was the configuration of the platform, what were the compute resources that were used, what were the inputs and the outputs, and being able to snapshot that intermediate state so that you can not only know what resulted in this current state, but you're also able to walk through your executions, or you're able to rerun your past executions to achieve the exact same output. So it's sort of like, a combination of two things, being able to snapshot the state as well as being in a position where it's almost trivial to re-execute from that captured snapshot. Now, one important ingredient in this captured snapshot is your third-party dependencies. As you can imagine, anytime you're doing any kind of processing, it is very likely that you are relying on code written by other people, predominantly in the form of other packages. And now in the machine learning universe, these packages oftentimes have a Pythonic interface, but behind the scenes, they may be relying on other non-Pythonic libraries.
Yeah, we talk about that a lot these days with Rust and C and so forth because of the speed with it. And there's also new sort of challengers have entered the ring recently.
Exactly.
So
Exactly. And in that particular universe, you can imagine now for a data scientist, it becomes incredibly important to be able to specify what kind of dependencies do they want to bring along their code and execute it rather rapidly. And there have been a bunch of projects in the space. I mean, I think Docker containers are sort of like a big one here, where people can go ahead and create these sort of like Docker files, slap their code inside, and then sort of like expect things to execute in a reliable manner somewhat. But
right.
one of the big issues with authoring a Docker file is that it demands too much from a data scientist. You also then have to figure
Yeah.
out where exactly is that Docker file going to live, where exactly is that Docker image going to live, how do you actually create these Docker images in the first place.
Right.
And that can inhibit your pace of iteration quite a bit, right? Especially if you're, let's say, at the earlier stages of building your model and you're trying to still figure out that, okay, what is the right version of PyTorch should I be using, or what is the right version of this library or that library? You want to be able to experiment quite freely. And if, let's say, your development loop is all about, let me bake a new Docker image, try it out. If something is wrong, then I'll create yet another Docker image and then sort of like run my entire workload again on top of it. That can be slow at times.
Yeah.
So what we provide within Metaflow is this library of decorators. So Conda is one, at PyP is yet another decorator, where within every step of your DAG, and we can sort of like talk more about DAGs in a bit, but within every step in your DAG, you can associate library dependencies. And these library dependencies can come from the Conda universe, or these library dependencies can come from the PyP universe. The reason why we offer the Conda universe is because Conda takes care of both your Pythonic and non-Pythonic dependencies, which is going to be the case if you are doing anything related to machine learning. But oftentimes we do come across scenarios where people have packages that are only available in PyP, so being able to sort of like mix and match these pip and Conda packages sort of like is really useful. And what we end up doing behind the scenes is we'll create the environment on the fly, we'll capture it, we'll snapshot all the individual packages. Metaflow will store those behind the scenes for you. And whenever you're running any workload, whether it's on your laptop, whether it's on your colleague's laptop, whether it's in the cloud somewhere, whether it's a Kubernetes cluster or an HPC cluster, then we are able to very rapidly recreate the exact same environment for the user without them having to become an expert in Docker. So that's basically the functionality that we offer with these two decorators.
Yeah, I think about Docker trying to teach yourself everything. Back when you're like learning Python, you're like, oh, and if you want to do a certain amount of stuff, you're going to need to learn this whole platform of setting things up. And the advantage in some ways was the idea that it could be hosted in different places, which is kind of neat, this sort of portability of this container. But learning okay, I need to learn a new markup language. I need to learn this thing. I need to learn all these sort of configuration tips and tricks and security. Okay, I need to know that. Um, and so there's a lot to it. So you're right that ends up being quite a bit. And so I like that idea. That's really kind of neat. This idea of sort of abstracting it a little bit.
Mhm.
Maybe we could talk a little bit about that. I would feel some people might not be aware if you are maybe more on a Pythonic side as opposed to a data science side of what's available in Conda and PyPI. I know that I should just have a whole show on it. But my experience is that on the Conda side, you're getting a lot of these larger, almost collective packages. If you've ever tried to set up PyTorch on your own personal computer, you may have struggled. Depending on the operating system that you have. You may have tried to use it with a version of Python that it wasn't supported in. And so you might have gone through hurdles. A pretty common theme that I do every couple weeks is I download a project and want to talk about it on the show. And so it's really nice if I can run that project. And if it's an elaborate data science type project, just me going through the machinations of like setting it up and not just simply, oh, I just want to pip install it from PyPI or whatever. It's a lot. And so the Conda environments are usually more complex. Would you agree that they have a lot more potential scope? We mentioned that they might have Rust or C or other kinds of packages involved. Sometimes they even have data with them.
Mhm.
And like I said, I'm in and out of that world a lot and talking about it. But what's nice about this is more than simply making a requirements.txt file
Mhm.
to say, I want to reproduce this thing and maybe potentially, like we were joking about NumPy just a minute ago, having the NumPy less than 2.0 in your requirements designation there to make sure it doesn't, accidentally install that. What are there's even another layer there that is kind of important of like we've talked about a little bit on the show of lock files, this idea of like
Mhm.
specifying this very, very specific version, not only for making sure that the code runs properly, but also for the sort of security in a way too, and making sure that this is the authentic one from the source where I got it. And so this is all kind of included there.
Yes, yes. I mean, software supply chain is definitely a big topic.
Yeah.
And I think the security implications of that are going to be a lot more important going forward for the world of machine learning too. So now, when we think about Conda, it can mean one of many things. So there's the universe of virtual environments. So you can create a virtual environment through VN. You can also create a virtual environment through Conda, for example.
Yeah.
You can create, in many ways, a virtual execution environment like containers. Linux containers are also a similar concept, with all providing varying different levels of granularity. Now, one benefit with running, let's say, a virtual environment through Conda is that you can run that inside a Docker container.
Yeah.
Versus, let's say, if your authoring experience already is a Docker container, which many cloud IDEs sort of like provide, then being able to run yet another Docker container within that Docker container is usually not really feasible. But you can always just create a brand new Conda virtual environment, and that's usually a lot more straightforward to do. So that's sort of like one big benefit. Also, you're able to virtualize Python. So on a single system, you can have different versions of Python as well. I think newer versions of Python come out ever so often. And if you just want to, let's say, even benchmark different performance profiles across different versions of Python, that becomes easy. So there's that universe of virtual envs that Metaflow will create on your behalf. So that's one thing.
Okay.
Then the next thing is, where exactly are these packages coming from? So that's yet another connotation when people use the term Conda. So in this case, all of these packages are coming from Conda repositories. And in the Conda universe, repositories are called channels. And you have many of those. There's Conda Forge. They're like Conda channels related to packages in the biology world as well. So we are able to use these package managers, Conda, MicroMamba, Mamba as well. And I think Wolf's team is working on this new project called Rattler, which is an implementation of Mamba and Rust, to create these environments on the fly very rapidly. Now, one big issue is that the exact nature of these environments is very temporal in nature.
Okay.
So if you, let's say, fix your version of PyTorch and try to install PyTorch today versus if you install PyTorch tomorrow, it's still likely that you'll get different sets of transitive dependencies because there may be certain other dependencies that are still floating. And that's where the concept of having a lock file becomes really important. And Metaflow will automatically create a lock file for you behind the scenes, so you don't have to worry about that. And it will also snapshot all of these individual packages in the blob store for you. So even if, let's say, tomorrow, I don't think it's a possibility that will happen, but if for whatever reason PyTorch is no longer available in open source, somehow somebody just goes in and deletes that package is still available inside your blob store. So all your workflows will still continue to behave as before. You're not sort of like at the mercy of the availability of any upstream repository at that particular point. And conceptually, what we are doing is we are just generating that thin top level Docker image layer, and we are just shipping that around depending on where you are executing. If you're executing on your laptop or inside another Docker container, then we just download that image and then that image layer, and then we just switch over to the Python interpreter in that layer and execute that user code behind that. So that sort of like, then enables a whole bunch of benefits that I just spoke about here.
Building AI apps comes with a lot of challenges. Many developers rely on open source code and software to jumpstart work. If you're building an AI app, save time and effort by visiting intel.com/edgeai. Here you can get open source code snippets and sample apps for a head start on your app. Intel.com/edgeai gives you access to real-world AI applications that can help you accelerate and optimize your models and deploy faster. You can also tap into GitHub notebooks for a range of applications from computer vision to generative AI. Check it out at intel.com/edgeai. Yeah, so when you mentioned this blob store, maybe we could talk about that briefly, like what is being included there. Is it an entire copy of the libraries and the dependencies, or is it more just lock files to make sure that it downloads the appropriate locked versions of all the very, very specific in time versions of these things? So like, what's the difference there?
Yeah. So what we store are the log files that point to individual packages that are also stored in the blob store.
Okay. And the blob store is stored where?
Could be a cloud blob store like Amazon's S3, Google's GCS, Azure's blob store.
Okay.
Could be MinIO. So totally up to people's preference.
This is part of you setting up Metaflow then to sort of indicate where you want these, I don't want to call them meta files, but I don't know what else to call them, but they're like these additional files that have to do with the infrastructure of Metaflow to save the snapshots, to save these other, sort of indicators. Am I right in describing that?
Yes. So the very basic infrastructure requirements that Metaflow has are rather minimal.
Okay.
If you want, let's say, all of this caching, snapshotting functionality, so by default, if you just pip install Metaflow today, then it will cache everything on your local file system. But if you configure Metaflow to use, let's say, an Amazon S3 bucket, so if you provided the credentials as well as the name of the bucket, then all of this data would be stored in that S3 bucket. Now, these log files are already part of the code package. So we snapshot the user code. And when we are snapshotting the user code for the execution, at that particular point, we also store that log file. And then all the packages are stored globally once for an entire organization. So you don't sort of like pay the cost of uploading this package over and over again. It's sort of like just a one-time activity. If, let's say, that package for whatever reason does not already exist in that blob store.
It's interesting because it feels like there might be some friction in an organization getting used to this workflow because of what they've been doing up to now. They're like, okay, but all my code is in Git and all my dependencies are done through poetry and all these sorts of things. And is it still like you would want those things happening also, like a belt and suspenders kind of thing?
Yeah. So, I mean, none of these things replace any kind of existing engineering process that an organization would have,
Okay.
right? So we are snapshotting code because we want to provide reproducibility so that you can, let's say, answer this very basic question that, hey, I had this person on my team who 6 months ago trained this model. I want to figure out what was the code that resulted in the generation of that model. I want to re-execute that code using the dependencies that that person was using at that particular point in time. So give me sort of like that entire execution context. So we'll be able to provide you that. Now, if in addition to that, you also wanted to store that code in your Git repository and have sort of like an entire CI/CD process, of course, all of that still applies. This is an internal implementation detail of Metaflow that just sort of like, enables some extra set of features.
Okay, so best practice is to still keep doing all of those things. And this is this kind of unique situation where you can do what you're talking about. Like that sounds fantastic if somebody took a job somewhere else and you're like, okay, well, what were they doing? Or
Exactly.
something happens, right?
And the problem with the problem with best practices is that they are very rarely enforced.
Right.
So imagine if, let's say, you are a data scientist and every single time you're, let's say, executing some script to train your model, the expectation is that without fail, you are going to create a Git commit and everything will be explicitly cataloged. Then that sort of like, just introduces yet another cognitive tax
Right.
on the individual.
Yeah.
Versus, let's say, yes, of course, it's a best practice that you should be cataloging everything rather explicitly, but then there is an implicit cataloging that also happens without fail that you can always rely on. There are certain guarantees that the infrastructure provides that are not reliant on the user taking certain specific actions. That's a big win. You can imagine there have been innumerable times this has happened, both back during my time at Netflix as well as sort of like working with many customers at Outerbounds, where people want to know something went wrong. What were the exact packages that were used to generate a specific model? Or maybe there is some security vulnerability and they want to triage every single model that was generated through some certain package. Just even understanding that, yes, this is a capability that somebody would need, expecting a data science team to build, keeping that perspective in mind, can be a big ask. And usually the expectation sort of like, falls on like, hey, the platform should automatically offer this thing for free.
Okay. Question on the snapshotting.
Mhm.
When does it happen? Like, it sounds like an opportune time is like the moment that you run something. It's like, okay,
Mhm.
during this process, now I'm going to go ahead and grab it. In fact, there's a kind of another new feature that maybe this would bleed into this idea of these cards where you can kind of see the processes of things running that kind of maybe go beyond what you'd see in like a command line environment. Maybe we could talk about that a little bit, but I'm just kind of wondering like, okay, when does this, these versions of the snapshotting happen?
Mhm. Yeah, I mean, anytime you're running any workload,
Okay.
we would want to snapshot it right before executing that workload.
Okay.
Yeah, I mean, one simple thing here is, imagine, and I'm pretty sure like many data scientists who might be listening to this show would have run into the same problem where something either works or maybe it fails on their laptop, but nobody else is able to reproduce that exact same execution environment.
Yeah, it's an interesting thing. Very cool. Like the very reproducibility of the problems.
Exactly.
Like, well, how was it configured? And you're like scratching your head. I don't know. And it's like, well, this will have
Exactly.
an exact snapshot. Okay, cool.
Exactly, and just with sort of like a few clicks, you're able to get the exact same code. You can run it again, and you're guaranteed that you have the exact same execution environment that your coworker had. So you can sort of like, if the thing worked, then it should work for you. If the thing failed, then it should fail on you as well.
I have kind of a related question there that has to do with scaling back to this idea. And we've talked about it already,
Mhm.
definitely the first time you were here where we were like talking about, okay, this person starts out on a notebook or laptop and they're creating this project and now they do want to move it into this larger environment. I think we've touched on some of the special considerations, but are there things that they need to keep in mind is like, okay, what OS should they be using, or should they be looking at unique builds of a particular library that they need to keep in mind? Are there or those types of considerations they need to be looking at?
Yeah, it's an excellent question, and I think it's also, one of the most important but overlooked detail. You can imagine, I mean, Macs are rather popular as developer environments.
Right.
And it's likely that if you're running something in the cloud, then you would be running on maybe sort of like a box that's running Linux or some flavor of it, or maybe it's some custom architecture. Maybe it has GPUs attached. Maybe it's like TPUs or something else, and that's a different architecture all along. And now a big question is, what packages should I be using? What builds I should be using? And those are details that can flummox even the most sophisticated of engineers and data scientists, right? And those are not the details that you would nominally expect a data scientist should be spending hours and hours of their working day towards. I mean, data science, it's a very deep expertise. It's also very lucratively paid, and as an organization, I wouldn't want my data scientists to bang their head against a problem that should not exist
Right.
in the first place. So one of the things that we do behind the scenes is we automatically figure out what are the right build packages, what are the right architectures for which we need to create these environments for, and then we ship those around.
Okay.
So those multi-platform, multi-architecture environment support is something that just comes out of the box. So you can be running on, let's say, a Mac machine and pushing your workloads on top of TPUs, on top of ARM architecture instances, on top of Linux instances, and we'll figure out behind the scenes what are the right set of packages and how to actually go ahead and create those environments for you, as well as keep them reproducible.
So I could kind of see that as far as Outerbounds helping with that, because that's a service that you're providing in there. If someone's using vanilla Metaflow itself and trying to structure some of these things themselves, is that sort of scaling, if you will, for a really limited use of the word? Is that part of it? Because I feel like it's like, this sort of picking from a menu, like, okay, well, which direction do we want it to go from? Is it covering both sides of that? Like, the hosted versus the other version?
Yeah, so I think there are two things, right? So when it comes to figuring out intelligently what packages should I be actually pulling down,
Yeah.
that's a Metaflow open source feature. So that's available to everyone. That's available to Outerbounds customers. That's available to anybody who's using Metaflow. Now, this also brings a rather interesting question here as a follow-up, which is, I'm running certain workloads. Now, machine learning can be rather expensive from a compute footprint point of view. And it makes a lot of sense to optimize your compute instances. Many times it could mean that, hey, am I running workloads that are just suboptimal on a given instance type? Should I be changing that? Or should I be rewriting my workflows so that I can actually use, or I can actually access all the raw compute power that I've provisioned for myself? And in that particular universe, we have, one of the features that you highlighted, cards, that sort of like comes in handy to get sort of like more deeper and fine-grained observability into the performance of your training workloads or your inference workloads, so that you can make that determination all by yourself.
Okay.
And then within Outerbounds, we provide sort of like an intelligent form of this feature where we can figure out what are the right instance types for people to run their training workloads on, so that we can reduce their costs even further in an autonomous manner.
Okay. So I'm still a little fuzzy in the sense of, again, going for like a company that's not using Outerbounds, they're using the open source Metaflow, and is it suggesting these avenues that could potentially, it could run this code with this, this architecture, or is it one of these things where you have to kind of plan for it and it's going to help you get those particular packages in the process of setting it all up? That's kind of where I'm wondering, like, where's the assistance happening?
Yeah. So now, if let's say when you are using open source Metaflow and you want to run a workload, then you have to also specify where exactly is that workload going to execute. Is it going to execute on your local laptop, or is it going to execute somewhere in the cloud?
Right.
And because we understand when we are running on your laptop what architecture that is, as well as we have an understanding of what that remote cloud computing platform is going to be, we can make the determination
Okay.
that what is the architecture, what is the platform that that workload is going to run on, and then make sure that the right packages are made available for that workload. So all of that happens on the open source side.
Yeah. You have provisioned these resources, and either you're running it locally on whatever your machine has as far as resources, or you provision these other things in the cloud, and it knows what that infrastructure is and can grab the appropriate stuff for it.
Yes, exactly.
This week, I want to shine a spotlight on another Real Python video course, and it's titled Everyday Project Packaging with PyProject Toml. In this code conversation, you'll follow a chat between Ian Curry and Gerarna Hiela, demonstrating the relatively new, officially sanctioned way of setting up your Python projects using a PyProject Toml file and installing your package with pip. This technique has a good set of benefits, such as being able to call your project from anywhere, playing on the same team as the import system, and allowing for consistent imports, along with having one file that'll work for many build systems. Along the way, you'll learn about structuring files and folders in your project, understanding different ways to run your script, exploring how the import system works, along with exploring the Python packaging world. You'll write a Python project toml file to configure your package, and learn how to install that package with pip. You'll also dive into the various rabbit holes along the way as Ian and Gerarna talk about the aspects of the process. Real Python video courses are broken into easily consumable sections, and where needed, include code examples for the techniques shown. All lessons have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the enhanced search tool on realpython.com. We touched on cards a couple times. Maybe you could describe them and what that change was, like how they've improved it. You have kind of a few videos and some links, and I'll include those in here. What's the idea behind cards, and how is it helping out with the platform and observability, if you will?
Yeah. So monitoring and observability, I mean, of course, that's a big question always, especially in the world of machine learning. But depending on who you ask, their understanding of what exactly monitoring means or what exactly observability means can vary significantly.
Yeah.
So, of course, being able to monitor the performance of certain statistical metrics for your training workload comes under the definition of monitoring. Being able to understand what is the utilization rate of your GPU is also under the purview of monitoring. Being able to track how some of your business metrics are moving is yet another definition of monitoring. And another aspect here, which is kind of like orthogonal but somewhat related, is how you would want to visualize these things that you want to monitor. And that can also be highly context dependent. That can be dependent on who is the end consumer. Of course, you do not want to send AUC scores to your product manager or your CEO. Right. What they care about would be very different than what, let's say, a data scientist would care about. And cards are an effort where we basically provide this capability to data scientists that they can, with just a few lines of Python code, create these custom visualizations that live alongside all of their models that get refreshed automatically whenever there's any new execution of the workload. And of course, everything is snapshotted. You can go back in time and you can look at sort of like prior executions of all of these cards as well to effectively monitor these workloads across this entire sort of like wide spectrum.
Yeah.
And one functionality that, or like one enhancement that we released very recently was this notion of dynamic cards. So up until very recently, these cards were actually generated once your workload had finished execution. So you could sort of like monitor, or you could look at the card once everything was done. And now these cards will start rendering much sooner. So you can have these dynamic cards that sort of like auto update with fresh information as and when that sort of like comes along. So if you have a rather large, let's say, distributed training run that you want to monitor, and maybe it's going to take days or weeks, and you want to keep a tight eye on how quickly is the model converging, or what is the actual overall infrastructure utilization rate, you can very easily create these cards and attach it to any of your workloads and start monitoring those. So that's basically is the thinking behind this feature.
I feel very often in this sort of environment of running large data science projects that often it was just hit a button and wait. And you weren't getting a lot of the observability unless you had designed a lot of it yourself. So this is maybe simplifying some of that, where you can say, okay, you can show the progress of, the data being loaded, the model being created, all the different sort of variations of things. And so you can kind of get these, in some ways, simple progress bars, but also like, the activity monitor, if you will, of what's happening with
Yeah.
all this infrastructure that isn't necessarily on your, local laptop, which is neat. I like that idea, because I've seen people, try to optimize things, and it's like such a rabbit hole that you can go down, and you can't really tell what's happening where unless you add lots of other sort of infrastructure on top of it. And we've talked about that, like memory and these other kinds of tools to like dig into that. And you kind of become a bit of a specialist then. And this is maybe at a level that you don't have to be quite
Mhm.
that level of a specialist to at least get an idea what's happening with it. And then maybe you could maybe bring somebody in who's, great at optimizing or whatever, and could help you with it. But it's interesting that way. How long have you guys been working on the cards thing?
So I think the first release of cards was maybe 18 months ago, and then the recent one
Okay.
is like a few months worth of effort on our part. But I think, yeah, you've raised sort of like, a great point that I think what a lot of people forget is, for machine learning, I mean, it's science at the end of the day, right? So when
Right.
you get started on the project, you have no idea what shape or size it's going to take. Is it going to be a dead end, or is it going to be a stellar success for the business? So optimizing for that pace of iteration becomes really important. And once you know what the end goal is, then of course, then the next sort of like hurdle comes across, which is like, okay, how quickly can you productionize those things? And that's been our emphasis with cards and many other features as well, that how do we make sure that we can provide more power to the data scientist, so in many ways they can become a full stack data scientist without actually understanding or like going sort of like, super deep into specific technologies around, let's say, observability or like, compute, but then also ensure that their finished product is as close to a production grade product as is possible, so that then you don't have to again engage in any kind of busy work to translate all your research ideas into something that is sort of like production worthy.
Yeah. One of the things that we've talked now, kind of going back and forth between these different environments of hosting, something locally, setting it up, and then moving it. And then you mentioned briefly the idea of GPUs being involved in this whole process. And it's kind of a weird mad rush right now for GPUs. Like if you read any of the news about what Meta is trying to do, of like literally gobbling up the supply of them. So I could see how different infrastructures, and depending on the companies, they're looking for this power, because that's what this stuff runs on the fastest in general, as far as these types of workloads. Are there things that you guys as a team have looked at to try to help in that sort of struggle to get as much as people possibly can out of the GPUs they have?
Yeah. So they're like, so we have efforts across a few different dimensions. So you can imagine right now GPU availability is rather constricted.
Yeah.
So we definitely want to make sure that people can make the most out of whatever GPU resources they have available. So, of course, cards help in monitoring whether you are making optimum use of their GPUs. And then we have many other profiling related features as well that allow you to eke out just like, maximum performance out of these. So that's one. But many times people have willingness to pay for GPUs, but they just aren't allocated any kind of availability by their primary cloud vendor, and that forces them to look elsewhere. and that elsewhere could be yet another cloud. It could be a specialized GPU cloud, or it could be just like investing in some limited on-prem resources as well. And at the end of the day, if you have to train a model, you have to train a model. There isn't sort of like any two way around it.
Need to get it
But
done.
yeah, you need to get it done. But one of the big hurdle that then it presents itself is that now your data scientist has to contend with infrastructure that's split across two different providers of compute
Oh, okay.
capacity.
Yeah.
And that's one functionality that we have worked on solving within Metaflow and Outerbounds. So Metaflow, as you know, now works across all popular clouds. So we have significant adopters, including folks at Amazon and AWS who use Metaflow to power their Prime Video recommendations as well as their e-commerce recommendations. We have users across GCP, Azure, Oracle Cloud as well. Companies in the Gen AI space like Adept have been using us across Oracle as well as their on-prem infrastructure. And of late, what we have also focused on is introducing capability where you can combine resources from two different clouds. So imagine if you are on, let's say, AWS, but for whatever reason, you cannot get access to H100s, but Azure is able to provide you that capability. Then behind the scenes, we can construct a compute fabric that is composed of compute instances, both from AWS and Azure, and seamlessly migrate your workloads across these clouds, while the end user doesn't really have to care where exactly that workload is running. Of course, there are sort of like open questions that come in with the economics of data migration. If you're moving data from one cloud to the other, that can be rather expensive. But in many use cases, especially let's say fine-tuning related use cases, you can actually get a lot done with this sort of an approach.
It's funny. Yeah, we got an appointment this Thursday. They have an opening to run our stuff here. But I can imagine that if you're, like, there's the idea of creating these large language models or other types of models and so forth. There's timelines that need to be met, and yeah, that's interesting. So that's cool. So it's something where there's some flexibility in there that you can kind of point this existing thing toward this new stack, if you will. Yeah.
Exactly. Yeah, you can point this new thing without your data scientist being bogged down by the detail.
Okay.
And I think that sort of like, again, harkens back to your first question that, okay, what is human friendly? And we don't
Yeah.
want the data scientists to be exposed to this fact that, where exactly sort of like the state of GPU economics are.
Right. Well, we talked a lot about it in our first conversation about this, and you've already mentioned it before, just briefly, the idea of how much is the time of the data scientists waiting around to make things happen versus the cost of infrastructure. And, it's real mixed right now as far as that goes, but in almost all cases, someone waiting for something to happen or having to learn all of these other types of things that they don't specialize in, they could potentially look at the savings there. So one of the example stories that I liked that you had at the end of the SciPy conversation, just to kind of reiterate this idea of what we're talking about, the environments and the idea of snapshots and so forth, was the story of, and it was an intern at Netflix. Is that right?
Yes.
Okay.
Yes.
Do you want to tell that story real quick, so to kind of reiterate that idea? I just thought it was a great anecdote.
Yeah. So this was about an intern who had come back to Netflix for another internship. This intern was in our data science group. And if memory serves me right, they were working with, I believe, the package TF datasets.
Okay.
And you can imagine many of these machine learning packages, they move forward at a very rapid pace. So it is very well expected that what worked, let's say, a year ago may not work today because their transitive dependencies would have changed. And you can't just close your eyes and just upgrade all of these packages. There are going to be numerous breaking changes as well.
Right.
So this intern had a project. It was a very successful project that they had sort of worked on and was working really well for them. And then they left Netflix and then came back exactly a year later. And then they tried to sort of pick it back up. And of course, you can imagine as soon as you, let's say, start running a workload, with the exact same set of package dependencies, things are not going to work, because not only has the outside world changed, in many ways, the world inside Netflix had also changed, right? Like the
Right.
base OSs that we were running for our compute platform, any other clients that we were running, all of those things had sort of like moved forward. And that then resulted in them spending close to 2 weeks trying to get their internal developer environment working yet again. And keep in mind that this intern was only at Netflix for 16 weeks, or maybe even sort of
Okay.
like less than that, right? So maybe sort of like 12 to 15% of their time was just spent on trying to figure out, how do I get to the same state that I left a year ago?
Yeah, where I was working before. Yeah.
Exactly. And at the same time, they did have other workflows they had written using the exact same dependencies through Metaflow, which they were able to just like pick back up and start executing on. So they were sort of like, in this paradigm where some of the work that they had done within Metaflow, they were able to start making quick progress on top of it. At the same time, some other work that was using the exact same set of dependencies that they were relying on, but wasn't written using Metaflow, they had sort of like significant delay in getting it back to a working state.
Yeah, it's like coming back from a summer vacation yourself.
Exactly. And we see that happen quite a bit. And I don't think this is sort of like a unique situation that this person found themselves in. I think this is something that, even as a software engineer, I have run into it in like many other areas as well.
Yeah, or you get a new Mac and suddenly they
Yeah,
use these M processors. And
exactly. I
nothing
mean, I,
supports
I
them.
haven't. Exactly. And I think that's also one of the big reasons why I'm also strongly bullish on this concept of cloud workstations or cloud IDEs.
Yeah.
That if we can, let's say, just move your laptop into the cloud where there's a lot more predictability, where change management is a lot more simpler and easier, that can also take care of many of these issues.
Yeah, cool. So, Savin, I have these weekly questions I like to ask everybody. And the first one is, what are you excited about in the world of Python right now?
Good question. Many things, to be honest. I think we are definitely seeing a renewed interest in making Python enterprise grade. So you can imagine, I mean, of course, we are trying to solve this problem of dependency management or software supply chain
Yeah.
within Metaflow. But of course, there's an entire ecosystem outside of Metaflow, but still within the realm of data science. And I'm excited to see sort of like, new companies getting funded in the space as well, which is sort of like always a healthy sign. There are companies like Prefix and many others who are sort of like building net new projects in the space. So that's super exciting.
Yeah.
Also excited about people trying to push the frontiers of performance, either within Python or sort of like, by creating new packages, but with still sort of like a Pythonic interface, or still keeping themselves true to the usability paradigm that Python sort of like very strongly tries to enforce. So those are few things that keep me super excited.
Yeah.
I think we are definitely trending in the right direction, and the momentum just keeps on increasing every passing year.
Yeah, I think it's incredible that the PSF has gotten funding to have developers in residence, multiple, across not only Python itself and addressing this sort of, I don't know where they're at as far as the backlog of issues, but I know that it's got to be at least looking better. And then they've have two people that I've talked to about the security stuff and working in PyPI and thinking about just general developer security and so forth. So yeah, it's a lot of focus, and so I appreciate that there is some funding and some focus. I agree with you on that. Nice.
Yeah.
What's something that you want to learn next? Again, this doesn't have to be Python. It could be something outside the realm of programming.
I guess just like better time management, to be honest. I think the
Sure.
last sort of like couple of years have been an interesting joyride. So I used to be at Netflix, left Netflix to start Outerbounds, and being on the entrepreneurial journey stretches you in many different directions. So of course, there's sort of like, this constant, I wouldn't use the word struggle, but a constant effort to just be better at time management and prioritizing things effectively.
Yeah.
I don't think anybody can ever sort of like get into a state where they feel strongly confident that they have everything under control. So I think I'm on the same journey there too.
Do you look at systems like getting things done, or some of these existing frameworks, if you will, behind that? I never got far into it, but I followed a lot of I don't know, quote unquote internet gurus on this stuff, and it was intriguing a subject to follow because it was sort of technology adjacent, kind of looking at different things like that. But I'm not into it as much anymore. But I definitely have got a copy of the book and stuff. But
Yeah, no, I've looked into many of these systems and many of these recommendations as well. But like while I was growing up as well, there was a habit that I developed that has kept me quite organized. So I usually start off my day with just creating a quick checklist of everything that needs to be done.
Oh, okay.
And that checklist is always using a pen on a paper. And then as the day goes by, I get the psychological joy of striking those things off. So which is really good.
Yeah, that makes sense. Nice. What's the best way that somebody can follow the work that you do online?
I'm on Twitter, but I rarely post there.
Okay.
A good way to follow the work that I'm doing or my team is doing would be to connect with me on LinkedIn, to be honest. We post frequent updates around how the project is doing, any interesting stories that we have to share over there. So, yeah, please feel free to reach out anytime.
Yeah, it seems like you have a fairly active blog on Metaflow also.
Yes. So
metaflow.org, right? Okay.
Yes. So metaflow.org captures all the latest updates, and then most of the long pieces of content, they go on the Outerbounds blog. So that would be yet another place for people to look at.
All right. I'll make sure to include that. Great. Well, Savin, thanks so much for coming on the show again. It was really great to talk to you.
Thank you, Christopher.
And remember, don't start building your AI app from scratch. Save time by visiting intel.com/edgeai. Get open source code snippets and tools to jumpstart development and deploy faster. Go to intel.com/edgeai. I want to thank Savin Goyal for coming back on the show this week. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.